Okay, we continue back. In this part, we will define the finite element properties where we start to do our finite element mesh by clicking this attribute menu and click to the mesh. And because you are using line element, so I have to click line. And in this line mesh dialog box, you can specify now the structural element type. So in this case, I want to use a thick beam because we want to model the beam. And then you select two-dimensional. And in other interpolation order, you have only one option to use linear. And the number division here, select it to be 1. Okay. So I will rename it as 1 thick beam. One division. Okay, so just click OK. So you can see the setting will be on the left side. It's not assigned, it is gray in color. So in order to assign it, you have to select this first element and just click this thick beam one division by your mouse and just drag and drop. So once you start drag and drop, you can see that the color of this thick beam change from the gray color to a colored icon, stating that it is already active. So the same thing you have to do with the same with the next element, but by clicking this and you just drag and drop. Okay, so you can see that here on the bottom of it you have a message here stating that you have straight line has been meshed and straight line number 2 also has been meshed. So in order to see whether this is meshed or not, you can right click, you can click this element, right click and select properties, where you can see that on the mesh you can see that currently assigned attribute is given to be thick beam 1 division. So same thing also with the second element. You can click on the properties, under mesh you can see that thick beam 1 division has been assigned. Okay, so the next after this is to define the geometry. So you have to click on the attributes geometry, select your line. So I have to select here to be your 2D thick beam. So this is where you define the cross section for this element number 1 and element number 2. So in order to get your area of element number 1, I have to find the average area by getting the area at nodes number 1 and the area at nodes number 2. So if you still remember that in the PowerPoint, the nodes number 1 here is corresponding with the 200 millimeter here, and you know that the thickness of this structure is 1 mm perpendicular to the computer screen. So area number 1, area at nodes number 1 will be 200 millimeter times with 1 millimeter, giving that 200 millimeter square. And what is the area at nodes number 2? Logically, area at nodes number 2 will be, the length here will be 150 mm, because the length here is in between 100 and 200. So logically this will be 150 millimeter, and the thickness here to be 1 mm. So area here will be 150 millimeter square. So what is the average area? So the average area for element number 1, so I have to insert something here. So the average area for element number 1, average area for element number 1, okay, I just use short form, is 200 millimeter square plus 150 millimeter squared and divided by 2, and I'm sure that this is 175 millimeter squared. Okay, so the same thing has to be done with the element number 2. So the average area of element number 2, that will be, the area here will be 150 millimeter squared, and the area here will be 100 millimeter times 1 millimeter, then you get 100 millimeter squared. So here I have to put 100 millimeter and divide by 2, this will be 125. Okay? So now I can fill up the element number 1 area is 175 millimeter squared, and average area for element number 2 to be 125. Okay? So we go back to our LUSAS. So for element number 1, the cross section area is 175. So I just put here to be element 1. I click apply. So you can see that the setting is created on the left side and it's in gray color. For element number 2, that is 125. So I just change this one to be 2 and I click OK. So you can see that this is the area of element number 2 is created. So I will select this element number 1 and assign by clicking this element number 1, you drag and drop. So you can see that this element number 1 has been applied to this line. And for the second one, which is element number 2, I just select this element number 2 and drag and drop. So we have already assigned this area of element number 2 to this line. Okay, so the next phase will be to define, to put the boundary condition here. As you know that the boundary condition at the top here is a fixed because it is attached to a wall. So I have to select fully fixed here. So you select this node first, select this fully fixed by mouse and drag it and drop. Click OK. So you can see that it is constrained here and by horizontal force, vertical force and moment. Okay, so the last one will be the loading. So click on attributes loading, and you have a lot of loadings here. Concentrated force meaning that point load, body force is self weight, globally distributed will be the UDL. So in this case I will use concentrated load. Click next, and the load direction will be in Y, and the load is 100 Newton. Sorry, 100 Newton. I have to put negative because the load is acting up downwards. If let's say you have a upward force, then this will be 100 Newton. So this is point load. I click there to get a point load and click finish. So you can see that it's not active, the point load. So in order to make it active, you have to select this point by your mouse and select this point and drag and drop. So you can see that this blue color represent the load is applied at node number 3 at the bottom. So now we have already complete the modeling task, and now we can run the problem by clicking this button, equal yellow button here, solve now. So hopefully there is no error. So I have error here. I don't know what is the problem here. So I have to see no mesh. You have to see what is the problem by seeing this. No material. Okay, I didn't assign the material. I forgot to do that. The material is 200 gigapascal. So I have to go back to this attributes, materials, isotropic. And you can put here to be 200 gigapascal. And remember that your unit is in Newton and millimeter. Newton and millimeter. So this one will be exponent 9 Newton per meter square. So you have to change that one to be Newton per millimeter. So how to do that? You have to multiply by what? 1 meter is equal to 1000 millimeter. So you have to divide by 1000 to the power of 2. To the power of 2. And how much is that? Okay, so we can use Excel in order to compute. So that will be 200 exponent 9 divided by 1000 to the power of 2. So you get to be 1, 2, 3, 4, 5. 2 exponent 5. Okay, 2 exponent 5. So I can put it to be 2 exponent 5. Okay, this is material. Click OK. So because the whole line is made by the same material, I will select the whole thing by select your line by the mouse, and you can drag this one and drag it. So now you have assigned that material, and you can see that is it active. So I can run it again. Hopefully there is no error. So now I think there is no error. The black screen, meaning that you have no errors and no warning. So in order to see what is the required problem question here, determine the nodal displacement at middle nodes and bottom nodes. So meaning that I want to know what is the nodal displacement at these nodes and at these nodes. So you can right click on the deform mesh, click on the window summary, and click OK. Okay, so in order to see the values, you can see that this is the actual model before it's being deformed by the load, whereas the gray color here is the deformed shape of the structure after it's being applied the load. So you can see there is a changes here, meaning that the displacement here, you have a displacement at this point. So in order to see the value of the displacement, I can click values, find displacement, and in Y directions, and display the values. Okay, I have to check it again why there is no values there. Displacement in Y, show values of selection. So I have to select this. I do not know why this software doesn't give me the answer. You should get the answer there. Maybe this software is not compatible with the Windows 10. So another way to access it, you can click on the print result results, click on the displacement. Okay, I want to know at the nodes, finish. So you can see that at nodes number 2, the displacement is 0.143. Okay, and the displacement at the bottom nodes is 0.000343 millimeter. It's quite small. Okay, so that is the displacement. How about the forces? You can click on the diagram, stress in X direction, label values, just click OK. So you can see that the stresses here, okay, which is 100 Newton and 100 Newton there, suffered. Okay, click on the stress again. Okay, this is another way to do that. Another way, if you want to see the value of the stresses, you can click on the utilities, print results, stress to the thick to be. and under elements and click finish. So you can see that the forces in each element. Element number 1 at nodes number 1, meaning that at nodes number 1 you have forces that will be 100. At nodes number 2 of element 1 you get 100 also, so that will be this. Element number 2 at nodes number 2, which is this, to be 100 also, and element number 2 and nodes number 3 to be 100 will be at the bottom here. Okay, so that's all for today. And for your assignment, you have to find your own problem involving bar that you can find in any exercise book or in any reference book, and ensure that you use LUSAS to do to find what is the displacement at the I think you must use at least the first exercise. You have to divide the element in 2 sections. The next one you have to divide this element to 3 sections, and the final one you have to divide this element to 4 equal sections. So please do reports within 2 weeks, and if you have any question you can ask inside the Google Classroom and contact with me. Okay, Assalamualaikum.